Hey everyone, Mr. H here. We're going to continue with graphing. Going to move on to a couple of new ones, tangent and cotangent. We're going to do them all eventually, but we've done sine and cosine. Now it's time for tangent, cotangent. So the first thing we got to do is get one cycle, like the basic y equals tangent x cycle. Let's plot some points to do that. So I've picked 5 that are key points in the graph, and let's plot them. So let's go ahead and start with 0. What if x is 0? What's the tangent of 0 is what I'm actually trying to figure out right here. All right. And what I'm going to do to figure those out is use the unit circle. Either I just have it in my mind and I'm going to think about it, or I can go look it up. But that is the angle 0, what in radians, what is the output, which in this case, remember, tangent from the unit circle is the ratio of the x and y coordinates, y over x. So let me just jump over to the unit circle and I'll show you what I'm blabbing about right here, right? So I have it highlighted. The angle is 0. The point is 1 comma 0. So I'm thinking y over x right here, right? And the y is 0, the x is 1, so that will be 0 over 1, which is equal to 0. So the tangent of 0 is 0. And I'm going to do that for all those key points, pi over 4, pi over 2, 3 pi over 4. Oops, no, back that up. Down here, negative pi over 4 and negative pi over 2. Right? Those are the key points I'm using when I'm talking about it. I'm referring to those. Okay, so let's jump back to the handout and we'll knock out those points. So I know tangent of 0 is 0. Let's blow it up so it looks a little nicer, right? If I looked at pi over 4, that had the point root 2 over 2 comma root 2 over 2. So the ratio of those is equal to 1, right? Because they're the same. And then at pi over 2, the point was x0, y1, right? So that would be the ratio of 1 over 0, which is undefined because you get 0 in the denominator. Oh, we're going to have to graph undefined. That's going to look crazy. Okay. And then over here, the negative ones, that would just be a -1, right? And then this one is also undefined for the same reason. And you can see those points as well. Okay. So those are my 5 key points that I would like to plot on this graph. Maybe we'll do that in blue so it stands out a little bit. But I've got x0, f of x0, or y0, right? There it is. Pi over 4, 1. And then pi over 2, undefined. So what I'm going to do is put just a dotted line because there's no point there. And then negative pi over 4 is -1, and negative pi over 2 is also undefined, another dotted line. Those dotted lines are called asymptotes. Those appear when you have undefined values in a function. Okay, so I can kind of piece together what's happening, and then I can see as I get closer and closer to pi over 2, right, like I'm going this way, then the graph is going to increase. So I'm going to end up something like this. It's just going to keep going up, and then towards the negative side, it's going to go down, right? So that's what one cycle of tangent looks like. When you do graphs, you're pretty much drawing this, and then your period, phase shift, all those things might change, but it always ends up looking like that. And of course it repeats, right? That same thing repeats over and over. Like if you did a few cycles, you would just have something like that going on, right? Over and over. But otherwise, that's it. Okay. So what you're going to have to do is graph things that are more complicated, and you want to try to avoid plotting points like that once you know what this main thing looks like. In this one cycle, think about it as 5 key points. So the 5 key points are the 2 asymptotes, which are, you know, here and here, right? And then you've got a midpoint right there. And then, so we're going to call that the middle or the midpoint. And then you have what are called quarter points, which are these 2 points here. So when I refer to the words, you have asymptotes, midpoint, and quarter points. And there's 5 of them. Those are your 5 key values. Okay. And so when you're graphing something, here's just some helpful tips. If you're graphing a complicated something like that, you can follow these bullet points that might help. So one thing to note, the period is pi over b as opposed to 2 pi over b for sine and cosine. Because notice here the period is just from negative pi over 2 to pi over 2, completes one full cycle on an interval of pi units. The midpoint is typically at 0 unless you have a phase shift. The midpoint is just going to be at that phase shift, right? A phase shift is a horizontal shift. So if you shift this guy around, right, it's going to be wherever that midpoint ends up, okay? And then asymptotes are halfway, half of the period in either direction, right? So that's halfway, half of the period, half of the period, right? And then if you have a vertical shift, you're just going to shift this thing up. So it's kind of like your new x-axis. And then that can help to figure out your quarter points. Your quarter points are basically for the y values are just 1, unless you have an a, then they're the a, if there's a number in front of the tangent, right? Kind of, so they're going to stretch the graph out or shrink it. And then if you have a phase shift, it'll shift those up. So you can use these little helpful hints. The y values of the quarter points are c plus a, c minus a. So we'll go do some examples and I'll refer back to these little bullet points. And we have that same thing. If a is negative, reflects about the x-axis. All right, so let's try one out. Let's go to the next example, and maybe I'll refer back to all that highlighted mess. Okay, so we got 2 tangent x over 3. So the first thing I'm going to do is find the period. Let's actually do this in blue so it stands out a little bit. So the period is pi divided by b. In this case, the b is 1/3. Right? X over 3, same as 1/3 x, which that's pi times 3 over 1, just 3 pi. Okay, so your period is 3 pi. And there's no phase shift, right? So since there's no phase shift and the period is 3 pi, I can get my midpoint and my 2 asymptotes. My midpoint, I know, is just going to be right at the origin. And the asymptotes, these guys, I can already draw them. The values of those are half of the period. So I can take 3 pi, divide it by 2. That's just 3 pi over 2, right? That will define my x value. So that's 3 pi over 2, and that's negative 3 pi over 2, okay? And then those quarter points, the quarter points are right between the midpoint and the asymptote, right? So it's right here. That's a quarter point. But where on that axis is that point going to be? That's where this 2 comes into play, right? So let's call this 2 right here, and that's negative 2. Then my quarter point is going to be up at 2. And then down at negative 2 on this side. Okay, so you have that stretch. And then there you have it. There's the graph. All right. So that one just had period and a stretch. There's no amplitude for these because they just have no max, no min. So that number, that's the A, is a stretch. And there you have it. Okay, so hopefully that's making a little bit of sense. Okay, so let's move on. Let's graph this one. And I already pre-labeled the axes in a way that it's going to match this function. And you'll see that appear as we calculate some things. The first thing I noticed about this function is that 6 needs to be factored out. So maybe down here below, let's factor that out. So we have f of x equals negative tangent bracket 6, and that would be then an x minus pi over 6, right? Okay, because 6 times pi over 6 will give me that pi back. Okay, and now I can figure out the period, which is pi over b, which in this case, there's the b, right? So that's pi over 6. And I have a phase shift right there, which we call d. D is also pi over 6. Okay, so when I start to draw this out, I always know that there's going to be a midpoint at the phase shift. Okay, so the phase shift is pi over 6. There's going to be a midpoint there. Okay, and then half of the period in either direction should be an asymptote, right? So if I take half of the period, so let's go over here and do p divided by 2, which would be pi over 6 divided by 2, which is pi over 12, right? And in either direction of that phase shift, I should have an asymptote. If I add pi over 6 to pi over 12, right, that should be an asymptote to the right, which that's going to be, if I get a common denominator, that's going to be 3 pi over 12, which is pi over 4. That's why I have it all labeled there. There's your asymptote. Okay, and then the other one, if I subtract, I'll get pi over 12. There's your other asymptote. Okay, so now I can start to see my graph appear. Now I have to get those quarter points. The quarter points, now I have to play around with this negative. That's going to flip the graph over. So typically tangent increases from left to right, but now it's going to decrease. So my quarter points are going to be here and here. They're level with the y equals 1 because there's no number out front. If there was a 2 or a 3 out there, I'd have to move those points up and down. Okay, and then there's my cycle. Just draw a nice smooth curve through those. Okay, and then this one wanted us to do 2 cycles. So I'll do another one, and I have a nice spot over here to the left, right? So I could see my, just kind of mirroring what it looks like. There's going to be another asymptote, there's a midpoint, and then there's the quarter points. So a little complicated, but not too bad once you start getting used to it. Some are easier than others. That one is probably on the harder level because of all the crazy fractions. But give them a try, see how they go. If you get stuck, let me know. I can help out. Okay, I'll talk to you later. Stop there for now. Bye.